All right, today in probability we're looking at the addition rule. First thing we need to look at is what's called mutually exclusive. Mutually exclusive is this right here. When you have two events A and B, they're mutually exclusive if they have no outcomes in common, which means the probability of A and B is 0. Okay, now what does that mean? All right, let's say I roll a pair of dice. Okay, rolling a pair of dice. All right, what's the probability that I get a 5 or a 3? All right, well, we're wanting to find the probability of this one or this one. Well, first of all, is there any way possible to get a 5 and a 3? No, it's not. So these are mutually exclusive. Okay, so this is going to be the probability of rolling a 5 plus the probability of rolling a 3. That's what the addition rule is. We'll get more into that later. But let's look at this. What's the probability that you get an odd or a 3? An odd number or a 3. All right, now these are not mutually exclusive because 3 is an odd number. So if you roll a 3, you're getting an odd and you're getting a 3 at the same time. And that's not mutually exclusive. Mutually exclusive is when two events A and B, have no outcomes in common. They have no outcomes in common. Let's go back to this right here. What's the probability that I get an odd or a 4? Okay, now these are mutually exclusive because an odd number and being a 4 are two different things, and you can't do both of those. So these are mutually exclusive. Okay, now here's the addition rule. Okay, the addition rule is simply this right here. The probability of A or B is going to be the probability of A plus the probability of B minus the intersection. But if they're mutually exclusive, it's just the probability of A plus the probability of B. Okay, so the probability of A or B is going to be the probability of A plus the probability of B minus the probability of A and B. But if they're mutually exclusive, this right here is 0. So the probability of A or B is just the probability of A plus the probability of B, and this is 0 here, so that doesn't matter. Now let me explain what this means. Let's look at a Venn diagram. It might be easier to think about it in a Venn diagram. This is A, and this is B right here. Okay, let me put in a picture. All right, what's the probability of A or B? What's the probability that it's in A or that it's in B? Okay, well here's what happens. This is the probability of A plus the probability of B. All right, so here's A right here. So I'm going to kind of shade this in. There's A right there. So that's this one, shaded in. Okay, now the probability of B, I'm going to shade it with this black. So that's the probability of B. Okay, but if you notice, this right here where it's A and B, the intersection here, I've counted it twice now. I've counted it with the red shade, and I've counted it with the black shade. So I've counted this twice. So that means I need to subtract off the probability of getting A and B, which is this center here. This is A and B. See this right here? This portion, that's in the A circle and it's in the B circle. So that's A and B. Okay, so this is what we're looking at here. These are not mutually exclusive. Now, if I draw another one here, here's another Venn diagram. Okay, all right, here's A and here's B. These are mutually exclusive because there's no intersection between the two. Two events are mutually exclusive if they have no common outcomes. And right here, these are mutually exclusive because they have no common outcomes. These are not mutually exclusive because they do have common outcomes where they overlap right there. All right, so this is what we're working on here, the addition rule right here. The probability of A or B is going to be the probability of A plus the probability of B minus the probability of A and B. And if they're mutually exclusive, then this right here just goes away. And so right here on this one, the probability of A or B equals the probability of A plus the probability of B. And there is no intersection, so it's just that right there. Okay? All right, well, let's do some examples here. Maybe that might make more sense. Okay? So, let me get this in the picture here a little better. All right, here's number one. If two events are mutually exclusive, why is the probability of A and B equal 0? Okay, that's what we just talked about. There is no intersection, so that's 0. So let's see here. Here you go, right here. I think it's A. Here's the answer down here, yeah. The answer is A. The probability of A and B equals 0 because A and B cannot occur at the same time because they're mutually exclusive. When they're mutually exclusive, just like we looked at here in this picture a minute ago, these are mutually exclusive because you can't have A and B at the same time. This right here might be the probability of getting a 6, where this is the probability of getting a 4. You can't do both of them. So these are mutually exclusive. So the probability of doing both of them is 0 because they can't occur at the same time. All right, let's go to number 2. Number 2 right here. Oop. Determine whether the statement is true or false. If false, rewrite it as a true statement. If two events are mutually exclusive, they have no outcomes in common. That sounds good to me. I think that is true. And you can see the answer right there. Yes, it is true. If two events are mutually exclusive, they have no outcomes in common. Okay. Let's go to this next one now. Number 3. Determine whether the following statement is true or false. If false, explain why. The probability that event A or event B will occur is probability of A or B equals the probability of A plus the probability of B minus the probability of A or B. Okay, now, all right, this right here should be and. So this is false. So it's one of these three. It's not true. It's false. Right here, C. I think it's C. So here, the probability of A or B occurs is A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay? And again, like I said on this right here, when you have two events that are not mutually exclusive, there's an intersection here. The probability of being an A or a B is the probability of A plus the probability of B minus the intersection. See, when I add A and B together, I'm adding this intersection twice. So I've got to subtract it off. That's the reason I do that. Okay? All right, let's go to another one. All right, number 4 here. All right. Let me get this lined up better. Decide whether the events shown in the accompanying Venn diagram are mutually exclusive. Explain your reasoning. Okay. All right, look here. See, there's an intersection here. They're not mutually exclusive. So this right here, the events 1, the events are not mutually exclusive since they're, okay, since there must be at least one candidate. See, we were looking at presidential candidates who were governors, presidential candidates who won the election. Okay, there's some that were both. I could think of Arnold Schwarzenegger. He was a presidential candidate that was a governor, and, well, I'm sorry, but he didn't win a president. So that was a bad example. No, George Bush. He was governor, and he won the presidential election. So George Bush would be over there. Now, Arnold Schwarzenegger would be over here because he didn't win the presidential election. Okay, so these are not, so here you go, these are not mutually exclusive since there is at least one presidential candidate who was a governor and he won the election. Okay. All right. Let's go to another one here. All right, maybe I'll make this one make more sense. Decide whether this Venn diagram is mutually exclusive. All right. Movies that are rated PG. So we got PG movies in this blue one. Here we have movies that receive mostly negative reviews. Okay. Now, There are some movies that are rated PG that have negative reviews. So that's what this is right here. That's the intersection of the two. So these are not mutually exclusive. So if we look down here, these are not mutually exclusive because some movies some receive mostly negative reviews. That's what this is. They receive mostly negative reviews. So some movies that are PG do receive mostly negative reviews. Okay. All right, let's see what we got here. Number 6. Determine whether the following events are mutually exclusive. Explain your reasoning. Event A. Randomly selecting a female psychology major. Then event B. Randomly selecting a psychology major who is 21 years old. All right, now just right off, I'm thinking it's possible to be both of these. You're a psychology major and you're 21 years old. So these are not mutually exclusive. So these are not mutually exclusive since, let's see, right here, I think it's this one. It is possible to select a female psychology major who is 21 years old. It is possible. So they're not mutually exclusive. About 7. All right, determine if these are mutually exclusive. Event A, randomly selecting a voter who is registered Democrat. Okay. Event B, randomly selecting a voter who is registered Republican. All right, these are mutually exclusive because there's no way to be registered both. All right, so these events are mutually exclusive since it is not possible for a voter to both be a registered Democrat and be a registered Republican. Okay. And number 8 down here. All right, we got some numbers involved here now. A physics class has 50 students. Of these, 10 students are physics majors and 16 students are female. Of the physics majors, 2 are female. Find the probability that a randomly selected student is female or a physics major. All right. So we want to find the probability that a student selected is female or a physics major. Okay, that's going to be the probability that they're female plus the probability that they're a physics major minus the probability that they're both. It should be and. Okay, so there's what we're going to have to do. So this right here, find the probability that a randomly selected student is female or physics. So female or physics. This is what I'm looking for. Now I got to figure out what these numbers are right there and then add them together and subtract. All right, so what's the probability that a student is female? Well, there's 50 total students, it says. There's 50 total. And of these, 10 are physics majors. All right, right here. So that's right here. 10 out of 50. That's the probability that person's physics major. Okay. Now there's 16 students that are female. All right, that's this one right here. There's 16 out of 50 that are female. Now what's the probability that they're both? Well, it says right here, of the physics majors, 2 are female. So 2 are physics majors and female. Physics and female and physics. So there's 2 of those out of 50. And so there's my numbers. I just add them and subtract. So this is going to be 16 plus 10, which is 26 minus 2 would be 24 over 50. And if you punch that in the calculator, 0.48, which is what the answer was right there. Okay. This is round to 3 decimal places, so I probably need to put a 0 on the end there when I punch it in. Okay. Number 9. Of the cartons produced by a company, 4% have a puncture, 7% have a smashed corner, and 1.3% have both a puncture and a smashed corner. Find the probability that a randomly selected carton has a puncture or a smashed corner. All right, so we want the probability that it's got a puncture or a smashed corner. That's what we're looking for here. which is going to be the probability that it has a puncture plus the probability that it has a smashed corner minus the probability that it's got both of them. Okay, maybe you're getting the hang of this now. So this is what I'm looking for right here. Now, what's the probability that it has a puncture? Well, right there, 4%. So that's going to be 0.04. What's the probability that it has a smash corner? Right there, 7%. So it's 0.07. And then what's the probability that they have a puncture and a smash corner? Right there, 1.3%, which is 0.013. Now I think it just left these as percents because that's what the answer looks like over here. But if I add these up, that's going to be 0.04 plus 0.07 is 0.11 minus 0.013, which is 0.097. See, it said percent right there, so I didn't catch that. So move this back to be on 9.7%. Okay, so we're using that addition problem, the addition rule. Right here. Probability of A or B equals probability of A plus probability of B minus the probability of A and B. This is what we're using right here, the addition rule. Okay, let's go to number 10. Standard deck of cards contains 52 cards. One card is selected from the deck. A, compute the probability of randomly selecting a 6 or an 8. Okay, here it is right here. Probability that you get a 6 or an 8. That's going to be the probability that you get a 6 plus the probability that you get an 8 minus the probability that you get both. But these are mutually exclusive. I can't get a 6 and an 8 at the same time. So this is just going to be the probability of getting a 6 plus the probability of getting an 8. So a 6, there's 4 of those out of 52. And an 8, there's 4 of those out of 52. So if I add those, that's 8 over 52. And then get my calculator here and punch this in. Okay, 8 divided by 52. All right, 0.153. 8 to the 8 makes the 3 go up to 4, so 0.154. Okay, and you see the answer right there, so I'm good. What about this? Probability of 6 or 8 or a king. All right, probability of a 6 or 8 or king. All right, these are all mutually exclusive because you can't be a 6 and an 8, and you can't be an 8 and a king, you can't be a 6 and a king. So these are mutually exclusive. So this is going to be the probability of a 6 plus probability of an 8 plus probability of king. I'm running out of room here. All right, so probability of 6, there's 4 of those out of 52. Probability of getting an 8, that's 4 out of 52. And the probability of a king, there's 4 of those out of 52. So I add those up, it's 12 over 52. All right, let's punch it in. 12 divided by 52, 0.2307 makes the 0 go up to 1, so 0.231. And it looks good there. How about that? All right, then we have right here, probability of a 4 or a club. All right, these are not mutually exclusive. These are not mutually exclusive because it's possible to be a 4 and a club. So this is going to be the probability that you get a 4 plus the probability that you get a club minus the probability that you're a 4 and a club. Okay? Now, probability that you get a 4, well, there's 4 4s out of 52 total cards. The probability that you get a club, all right, a club, there's 13 clubs out of 52. Minus, now the probability that you get a 4 and a club, all right, there's 1 4 of clubs out of 52. So there's what I add and subtract. So 4 plus 13 is 17. Now when you do this, you can just add these top numbers right here since these are all the same denominators. So 4 plus 13 is 17, minus 1 is 16. 16 over 52 is my answer right there. If I punch that in, 16 divided by 52 is 0.3076. The 6 makes the 7 go up to 8, so 0.308. And you see right there, I'm perfect. Okay. About 11. you roll a 6-sided die. Find the probability of each of the following scenarios. So probability of rolling a 6 or a number greater than 3. All right, these are not mutually exclusive. All right, so that's going to be a probability of 6 or I'm just going to put a greater than 3 equals the probability that you're 6 plus the probability that you're greater than 3 minus the probability that it's a 6 and greater than 3. Okay, so probably getting a 6, this is a 6-sided die, so there's 1 6 out of 6 total sides. Probably that you get greater than 3, or it could be a 4 or a 5 or a 6, so there's 3 of those out of 6, minus the probability that you 6 and greater than 3. Well, a 6 is greater than 3, so there's one of those. There's 1 6 and it's greater than 3. So now I add these up, and that's just 3 over 6. 1 plus 3 is 4, minus 1 is 3. And if I divide that, I get 0.5. It says round 3 places, so I probably need to put these zeros on. So 0.500, you can see right there. Okay, look at this one. Probability of 1 or 2 or 3 or 4 or 6. All right. These are mutually exclusive. It's not possible to get 2 of these at the same time. So this is going to be the probability of getting a 1 plus the probability of getting a 2 plus the probability of getting a 3 plus the probability of getting a 4 plus the probability of getting a 6. Okay, now you probably can do this in your head. Maybe this is going to be 1 out of 6 plus 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 1 out of 6. So 1 plus 1 plus 1 plus 1 is 5. So it's 5 out of 6. And if I divide that, 5 divided by 6, 0.833. Perfect. Okay, what about this one? Probably getting 4 or 1 or 3 or 5. Again, these are mutually exclusive. It's not possible to get 2 of those at the same time. So it's going to be the probability of 4 plus the probability of getting a 1 plus the probability of getting a 3 plus the probability of getting a 5. So there's 1 4 out of 6, there's 1 1 out of 6, there's 1 3 out of 6, there's 1 5 out of 6. So I add those up. 1 plus 1 plus 1 plus 1 is 4. And that's going to be 0.66 repeating. Look here. 4 divided by 6, 0.6. So it's going to be 666, but this 6 makes that 6 go up to a 7. So 0.667. Okay. Number 12. All right, we're going to have to move this around a little bit because we got this pie chart down here. All right, number 12 says the estimated percent distribution of a certain country's population for 2025 is shown in the accompanying pie chart. Find the probability of each event listed in parts A through D. Okay. All right, so right here, randomly selecting someone who is under 5 years old. All right, if you look at here, we just look at this. Under 5 years old, that's going to be 6.2%. And it's percent, so we're just going to leave them as that. Okay. This one says randomly selecting someone who's 45 years old or over. Oop, get on here. 45 years old or over. All right, so 45 years old, if you look at this, all right, 45 to 64, 65 to 74. So it's going to entail all 3 of those. So I would add all 3 of them together. All right, so let me add those together here. I'm going to have 24.7 plus 11.9 plus 8. Okay, I get 45.2. Okay, 45.2. And I'm good on these first 2. You see my answers down here. I got this one, I got that one now. All right, let's go to the next one. Randomly selecting someone who is not 65 years old or over. Okay. All right, 65 years or older, it would be these 2 right here. Okay, so 11.9, 8.6. If I add those, it's going to be 20.5. Okay, so there's what is, this is 65 and over. All right, this says right here, selecting someone that's not 65, that's the complement, if you remember that. So all I would do here, it's going to be 1 minus 20.5, which is going to be 79.5. Okay, that's the complement, which is 1 minus the probability that it is. That's what not is. All right, and then part D here, randomly selecting someone who is between 20 and 34. All right, so between 20 and 24, that's 4.7. Okay. Oh, wait a minute, 20 and 34. So there's 20 and 24. So we've got that one. 25 to 34. I got to add both of these two together. So it's going to be 19.6. And I got the last two right, so we're in good shape. Okay. Here's another one. Same thing. I'm not going to do that one. Okay. All right, here's one, 14. It's the same type of thing, except that it's bars. Okay, so number 14 says, the responses of 1,416 voters to a survey about the way the media conducted themselves in a recent political campaign are shown accompanying Pareto chart. This is a Pareto chart right here, what this is called. See how they go down? That's what a Pareto chart does. Okay, find the probability of each event listed in parts A through D below. All right, so part A here. Find the probability of randomly selecting a person from the sample who did not give the media an A or B. They did not give them an A or a B. All right, here's A or B right here. So they did not give them that, which means it could be this one, or this one. So I add these together. So it's going to be 544, 290, 269. So I add these up, okay? So that's going to be 13, 1, 5, 20, 2, 7, 9, 11. There you go. That's what I get when I add them up. So there's how many did not give them A or B. Well, it says there's 16 total right here. That's how many total there are. So I do 1103 divide by 1416. And that would be my answer right there. All right, so let's do this real quick. 1103 divided by 1416, and I got 0.7789. You see that? 778, and the 9 makes the 8 go up to 9, so 0.779. And that's right. See? Okay. Part B, randomly selecting a person from the sample who gave the media a grade better than D. All right, better than D. That'd be C, A or B, and that's it. So I would add these two up. So I'm going to do 313 plus 269, which is 12, 1, 8, 5, 82 out of 1416. Okay? So 582 divided by 1416. And 0.411, the 0 does not make the 1 go up. So 0.411. You can see right here, that's right. 0.411. Okay. All right here. Randomly selecting a person from the sample who gave the media a D or an F. A D or F. All right. So here's D and here's F. So I would add 544. And the D is 290. So add these together. That's going to be 834 out of 1416. That's what I would do. That's what I would do there. So 834 divided by 1416, I get 0.5889. This 9 makes the 8 go up to 9, so 0.589, which you can see we're right there. And then one more, part D here. Randomly selecting a person from the sample who gave the media a C or a D. All right, look here now, probably a C or D equals probability of C plus probability of D minus intersection, which you can't do a C and a D, so it's just these because these are mutually exclusive. So that's what we're doing here. So I'm just adding these up. So C is 269, D is 290. So add these up, 559, and I divide it by 1416, which is the total. So let's see here, 559 divided by 1416 looks like 0.394. The 7 makes the 4 go up to a 5. So 0.395, you see it right there. Okay, here's another one. I'll let you guys do this one. Then we got a couple like this right here. For 16. Okay. All right, number 16. The accompanying table shows the number of male and female students in a certain region who received bachelor's degrees in certain field in a recent year. A student is selected at random. Find the probability of each event listed in parts A through C. All right, so in part A here, the student is male or received a degree in the field. All right, so probably that they're male or received a degree. I'm just going to put a degree in field. All right, so this is going to be the probability that they're male plus the probability that they've got a degree in the field minus the probability that they did both. I'm running out of room. Okay, because these I don't believe are mutually exclusive, because it seems like you could be male and get a degree in your field, so they're not mutually exclusive. All right, so what's the probability that they're male? So look at the thing down here. Here's my total right here. So males right there, there's this out of this. So I divide those two. Okay, so let's just do that real quick. 767,709 divided by 1696030. And I get this 0.452. The 6 makes the 2 go up to 3, so 0.453. Okay, now what's probably they got a degree in their field? Right? If you look here, degrees in the field is right here. So it's that out of the total. So I do this divided by this. So let's punch that in. All right, 271,303 divided by 1696030. That's 0.159. See, this 9 makes this 9 go up to 0.160. Okay, so I add them together, but then I got to minus off the probability that a male got the degree in the field. All right, if you look at the thing now, right here's the males that got a degree in the field right here. So I do this divided by the total for the probability of that. All right, so that's going to be 156,141 divided by 1696030, and I get 0.092. The 0 does not make the 2 go up. 0.092. Okay. Now, so I just add these and subtract that one. Okay. All right, so 0.453 plus 0.160 minus 0.092. And I get this here at 521. And you can see that's my answer down here, 521. Okay. Now, an easier way to do this, instead of dividing, because see, you know, the first one, the probability that they're male was this divided by this. Okay. And then the second one was this divided by this. And then the third one was that divided by this. And like we've done on the previous problems, you can just add the tops and then divide. So the easier way to do this, probably a whole lot easier, would to be 767,709 plus 271,303 minus 156,141, and get that answer, and then divide it by this. So divide that by 1696030, and look there, I got 0.5205, which the 5 makes the 0 go up to 1, 0.521. So it's a whole lot faster doing it that way. We'll do the rest of these this way, okay? It's like B here. The student is female or received a degree outside the field. So probably that they're female or degree, I'm going to put outside, DOF. All right, that's going to be the probability that they're female plus probably they got degree outside of field minus the probability that they're both Okay? So the probability of the female, now remember, I'm just going to do the tops, and I'm not going to divide till the end on this one. Okay? Now, let me go back. We'll go back to this. See, when I did these, 1 over 6 plus 3 over 6 minus 1 over 6, I can just do the tops. 1 plus 3 is 4, minus 1 would be 3. 3 over 6. It's a whole lot easier just to add their tops and then divide afterwards. So right down here, 1 6 plus 1 6 plus 1 6 plus 1 6 plus 1 6. Well, 1 plus 1 plus 1 plus 1 plus 1 is 5. 5 6. And then I can divide it. So that's what I'm going to do on this part B now. So the probability that the student is female or received a degree outside the field. All right, so that's this right here. So the probability that they're female, all right, female total is 9 2 8 3 2 1. The probability they got a degree outside the field, degree outside the field is right there. This is a 1 4 2 4 7 2 7 minus the probability that they're female and got the degree outside the field. All right, that'd be this number. 8 1 3 1 5 9. They're outside the field and they're female. So just add, subtract, and then divide by this number. It's a whole lot easier doing that. All right, so let's do it here. I got 9 2 8 3 2 1 plus 1 4 2 4 7 2 7 minus 8 1 3 1 5 9, and then hit equals. All right, so there it is. There's the total. Now I take that and I divide by this number here. Okay, so I divide by 1696030, and I get this right here, 0.907. Okay, and the 9 makes the 7 go up to 8, so 0.908, and you can see right there, man, that's perfect. Okay, all right, now the last one, part C here. The student is not female or received a degree outside the field. All right, so right here, I'm going to redo this right here. The student is not female. The complement of that is that they're male. So the probability that the student is male. Or received a degree outside the field. So that they got the degree outside of field. All right, so that's going to be probability that they're male plus probability that they got the degree outside the field minus the probability that they're male and got the degree outside the field. Okay, so the probability that they're male, all right, all my total males right here, 767,709. Probably they got their degree outside the field right here. We just did that one on the previous problem. Minus the probability that they're male and they got the degree outside the field. So they're male and they got the degree outside the field is right here, this 611,568. So I add those, subtract, and then divide by the total. It's easier doing it that way. All right, so I have 767,709 plus 142, 4727, and then minus 611,568. And hit equals, and I get that number there. And then divide it by the total here, 1696030, and I get this right here, 0.932. And the 0 does not make the 2 go up, so 0.932. And there you go. We got it right. 0.932. Okay. So this is the same thing here, and that's the same thing there. So I'll just let you do those. Okay. It's just the same thing we're just doing. And if you need help with them, let me know, and I'll help you all I can. But that's the addition rule. And contact me if you need help. Have a good rest of the day.